I've been watching YouTube videos about playing Minecraft. I was like, oh yeah, no, it's a good game, it's a good game. He said, have you got it? I was like, yeah. He said, can I play it? I was like, yeah, sure. So I set it up on the computer, and he goes, oh, have you got this mod? I'm like, no, I'll download the mod for him. And he goes, oh, have you got that mod? No, okay, I'll download that mod for you. I was like, you ready to play? He goes, yeah, great. So he sits down in front of the big monitor, the Razer keyboard and mouse glowing as they do. And he paused for a second, and he went, what's up, it's your boy J-Bo here, and today I'm going to teach you how to use this mod in Minecraft. And what I realized that he was doing was he was pretending to make a YouTube video about how to play Minecraft. And it's very sweet, a sweet little moment, but I keep that in mind as we go through here, because what I'm going to talk about is what playing Minecraft has taught me about DevOps. And by the me, I mean me, Richie Lee. I'm a lead DevOps engineer at a company called Redkite. A big fan of open source. I was the guy who wrote the deploy DAC pack functions for Azure PowerShell in the DBA tools PowerShell module. So if you've ever had a failed deployment through DBA tools, then you know who to blame now. And at the risk of mixing my metaphors, with Minecraft and Dungeons and Dragons, but in keeping with the theme of the conference, my D&D alignment would be chaotic good, apparently. And apparently copper dragons are typical examples of chaotic good creatures, so that explains the updated little dude colored there. So we're going to be comparing Minecraft and DevOps. Let's start with what is Minecraft. I'm sure all of you know what Minecraft is. I'm sure all of you have heard of Minecraft, and Minecraft is basically a kind of open world game. You can kind of go in any direction, and this world is a hostile world, really. Things will blow up in your face. And at the beginning, you're going to feel like you're surviving. But if you persevere with the game, you'll find that you'll thrive in the game, really. And you stick at it, and you're going to build some pretty cool things. So on the other side of this comparison is DevOps. What is DevOps? Well, I'm sure all of you have heard of DevOps. I'm sure all of you have seen DevOps. Again, it popularized around about 2009, 2010. It's kind of like an open, nebulous thing, really, DevOps. And it can be quite hostile to start off there, really. Things will blow up in your face, like SSDT, for example. And at the beginning, you're going to feel like you're just trying to survive through, working with this DevOps mindset. But, if you persevere, you find you're going to thrive. And, if you stick at it, you find you're going to build some pretty cool things. So, back to Minecraft. Let's talk about the very first night surviving Minecraft. So when you start off, you have a very small crafting area. You can't build much on there. So the first thing you need to do is go build yourself a crafting table, right? So in order to build a crafting table, you need some wood. So what you do is you go to the nearest tree and you punch it until you get some wooden blocks. Once you've got those wooden blocks, you can arrange them in such a way in your small crafting area to make a crafting table. With this crafting table, you can make more sophisticated tools. At the start, you're going to just want a wooden pickaxe, right? I mean, you can make a wooden sword if you want, or a wooden shovel, but first things first, just get the wooden pickaxe. Because the next thing you want to do is build a shelter. And for the first night, all you're going to need is just like to dig a hole and to put the dirt back over the top and hide in that. And the reason why you want to hide when it's dark is because mobs will spawn during the dark, or in the dark rather. So you need some place to hide. You've got really no way to protect yourself. And if you've got a bit more respect for Steve, that's the character that you play as in Minecraft, you could just go to a hill or a mountain and dig a small cave in there and then cover that up, so as opposed to like hiding in a hole in the ground, really. And then once you survive the night, if you assume the night, then you go and gather some food. So you go out, you find the nearest animal, a pig or a chicken. You go and kill it and you go and eat the raw meat. I apologize in advance for the people with animal rights sensibilities in the room. I am just talking about in the game, so But that's the absolute fundamental first off start thing that you need to do to survive the night. Eventually, you carry on. You get to a point where you do more interesting things, like encountering the Ender Dragon. So what you need to do, start off with, you need to go and get a diamond pickaxe. A diamond pickaxe, you need to enchant it with efficiency or fortune. You can do either or both ideally, right? It doesn't really matter. Then once you've done that, you go and mine for some obsidian to build a nether portal. And don't forget your bucket of water, because obviously that makes it easier to mine for obsidian. Once you've done that, you build a nether portal, you go through the nether, you go find a blaze spawn, you go and kill all the blazes to get some blaze sticks. Once you've got enough blaze sticks, you go back through, go find some endermen, kill the endermen, get some ender pearls. And then once you've got the ender pearls, you go and find the 12 eyes of ender. You go find the end. You go to the end portal. You go and encounter the ender dragon. Okay, simples, right? Now, depending on your mileage with Minecraft, that last bit about the ender dragon is going to make absolutely no sense whatsoever. But you know, we can all get the idea of what I was saying at the beginning there, with like, you know, building yourself a shelter and, you know, getting yourself some food and getting some rudimentary tools. And like, really, like, if there's one thing that playing clearly a lot of Minecraft has taught me, is that you may think you know where you want to get to, but if you don't think you know how, then all the mods in the world won't help you, right? You can download all the expansion packs for Minecraft, have all those tools, but if you don't know how to put them together, then it's just going to be a complete waste of time. So let's talk about an example of this. Using this DevOps Mobius strip here as like a frame of reference for how we're going to get through this, okay? So this is a real-world problem I had about 9 years ago. It's about modifying some existing tables to use clustered column store indexes, okay? So we had a data warehouse, had these tables. They were heaps, but that was fine because it was just the data was written into once and then read out from once. They were like cube staging tables for analysis services cubes. They were also partitioned, so in terms of the reading and the writing, kind of, you know, it was at the partition level, and the partitioning also reflected in the cube. So everything was kind of, you know, a typical process there. But we had a problem. These tables were huge, and they were getting bigger. It was, you know, getting difficult to back up the database, particularly when data loads were running. It was getting difficult to restore the database to other environments. You know, the actual size of the backups were becoming a problem. And just even in production, these tables were massive, and they were getting bigger and bigger and bigger. And despite the fact we had page compression on, it was still a problem. So when clustered column store indexes became available in SQL Server 2014, I immediately thought, right, let's use these, because this is great, because they give you like amazing page compression, or amazing compression rather. So these were fairly narrow tables, not many columns to them. They're all numeric data types, so we knew that we were going to get like, you know, great dictionaries and great segments out of compressing these using clustered column store. The only challenge was that these tables were existing. So with SSDT, you know, you can make some changes in your source control, and you can just push those changes out to production, right? So this is not the way we did it, but you know, if you take that literally, because that's what people say you can do with SSDT, let's work through that process, okay? So the plan is that we have a requirement to convert these partition heaps to use clustered column store indexes, okay? So in the source code, there's not much to change there. We go and find the create table statement. We go and add with clustered column store at the beginning, at the end of the statement, and then because there's an ETL process, there would be some store procedures that would create those partition tables that would be switched into those current heaps. So we need to go and update them to use with column store when they created those tables, because the tables that are switched in with partition, they need to be identical, okay? So the build process would run nice and quickly. You know, we had a pretty sophisticated build and deploy process. We had good testing as well using dbfit. So dbfit we would use to run the SQL agent jobs that would go and run the ETL process for us, and we would have like basic inputs, then compare the outputs in dbfit. It worked well. So we could confirm that the switching worked in dev with a fairly small data set, and then we would go and deploy it, and utter chaos, basically. Because, you know, not that we did it this way, but you know, if you know how SSDT works, what it would do in this case, it would create a new table with the clustered column store index, give it a funny name, and then it would copy all the data from the current live table into that new table, and then once it's copied all that data, it would drop the original table and rename the new table to the original table. That's how it manages certain types of changes. So if we'd done it this way, we would have just had utter chaos, because we'd had no control over when we'd release the feature, okay? As soon as it's deployed, it's released, it's done, it's in there. You know, when it comes to monitoring, there would be locks on the tables. You know, the massive log backups would be occurring. It would just be an utter mess. You probably wouldn't even be able to load into that table. So at that point, really, can you argue, is anything operational at this point? So clearly working that way with SSDT is like a really bad way of doing it. And, you know, so a lot of people give SSDT a bad rub. You know, they go, oh, it doesn't work, it doesn't do this, doesn't do what I expect it to do. And really, SSDT is just always doing what you ask it to do, okay? And it will blow up in your face just like a creeper would. And kind of, if we kind of push on with the metaphor with SSDT and creepers, you know, I was talking about earlier with in Minecraft, you can like dig a hole and hide in it. An alternative way would be to go and find a creeper, agitate it so he explodes, and then you've got a nice big hole that you can go and hide in, cover the dirt over with that, right? So you don't have to get a crafting table. You don't have to build a wooden pickaxe, okay? You can do all this instead, okay? And like, you can do this. This is one way of working, okay, with making a hole for the night. But then you've got risks, okay? So the first risk is the fact that you've got to go and find a creeper before the first nightfall. There's no guarantee that you're going to find a creeper. Secondly, once you go and agitate him to the point of him exploding, you've got to make sure you're outside of the blast radius, okay? So there's no guarantee you're going to be outside of the blast radius, and because you're not protected, you're probably going to die. Secondly, that hole, I think, is too big. The reason why I say it's too big is because there's some prerequisites for mob spawning, okay? One is it has to be dark. The other one is they need to have a certain radius around them in order for them to be able to spawn, okay? So that they don't spawn like where blocks are. So I think that hole is actually big enough to spawn like a zombie or a creeper or a skeleton with a bow and arrow or something like that. And so effectively, if you did it this way, what you would have done is you would have made a space big enough for a mob to spawn with you in this hole, and you would have just effectively dug your own grave, right? So you can do it this way if you really want to, but please don't, okay? Just like with SSDT, you can go and make the change, and you can let it all fall over, but please just don't do that. So let's talk about the way that we did do it. Same problem, okay? Modify existing tables to use clustered column store. So the first thing is, okay, so what we actually need to do is we need to move the data in the heap tables to clustered column store tables, okay? So we had, although there was partitioning, we had a bit of a wrinkle with this, okay? So for each table, they were in their own file group, but had their own files underneath them, okay? So what would have been an easy way is to create a new table on the same file group. Once you create that new table in the same file group, you could just switch out the partition, put clustered column store in that partition table, then switch it back in, okay? Nice, simple process there. The trouble is, because each table was on its own file group, had its own files underneath, those files were massive. And the whole point of this was to actually reduce the size of the files. So we had to do a bit of data movement across like files, which was going to take time. It's not that quick partition, switch in, switch out process, okay? So how do we go and plan around this? So we wrote a store procedure to go and do this for us. This store procedure would go and create the new table with clustered column store, and then it would switch out a partition and then like read the data into the new partition table and then switch that partition in. Because there was lots of data movement, it was going to take time. We wrote, we put a login table in. So we did lots of logging, okay? We just logged to a table. Everything that was happening, we go and log it. And then we had another table that stored the high watermark keys for the partitions, okay? So we could run it in bulk. We could do like a bunch of partitions, or we could just run a single partition. Well, we just wrote it so that we knew the last partition that was actually done, that was registered in the logging table, or in the high watermark table, so when we came to resume it, we'd be able to carry on with the process, okay? So no changes to the current data loading process. Absolutely nothing had changed, okay? So the SSD project would compile, you know, nice and simple, store procedure, a couple of tables. We test it using dbfit in dev and also in the pre-prod environment as well. We were quite lucky, pre-prod, you know, we were able to restore the whole database. We were able to test in, you know, basically test in production in there and get an idea of how things were running. And we started with small partitions first, so we could see how long it would take for them to move over, and then we could build our way up, and we could estimate roughly how long it would take to move a partition each time, how big the logs we're going to get, because obviously we don't want the log files to get absolutely massive. So once we actually deployed to production, we were just deploying a store procedure and a couple of tables. It's quite straightforward. Nothing had been released at this point. We deployed the object, but we weren't using them. They were just sitting there waiting for us to use them. With the current data loading process, there was no change, and with operations, there should be no change as well. Okay, so nice and simple. So the next process was, okay, let's run the store procedure. How do we get to run that store procedure? To move the data from heap tables to CCI tables. So write SQL agent job. Nice and simple. SQL agent job, you know, just run a store procedure. Scripted it out, put it in source control, parameterized, you know, things like instance name and all that stuff. In the build process, there was nothing to build because it was static script, so it was just sitting in source control. Came to test the deployment in pre-prod to make sure that, you know, all the variables were filled in properly. Deployed the agent job to production, again, made sure the parameters were populated, and then we just ran the SQL agent job. So SQL agent job run the store procedure. Now, we didn't write a schedule. There's no point in scheduling this. We had like windows of opportunity because this was a data warehouse, so there were times we could run this and move the partitions out of the current table into the new tables. Yeah. But we just kind of did that on an ad hoc basis. When we knew that we had some time to do it, we'd go and run it. And we could check how it was going by just looking at the logging tables. Just simple select queries on the logging table, see how things were going. And the operations of the loading into the current tables, that could carry on as normal, because as long as we were able to switch out the data quicker than data was being loaded in, we knew that we would get the data moved over eventually. Okay? It was just a matter of time. And it actually took us about 4 months to do this whole process. But it was controlled. We're being cautious. We're being careful. And then once we'd effectively moved all the partitions from the old table to the new table, the requirement was to drop the old original partition table, which was empty at this point. It was just a heap. Okay, it was just an empty heap. Sorry. So drop that and then rename the new one to the original name. So effectively doing what SSDT would have done, but in a much more controlled way. So again, write a simple stored procedure to drop the table and rename. Go through the build. It's a small stored procedure. Run it in pre-prod, because pre-prod was much like production. Everything kind of worked, no issues. We deployed it. We ran that stored procedure manually through Management Studio. There was quite a few tables we needed to do. So having the stored procedure just made sure we could put some checks in to make sure that the table was empty, for example, right? So we weren't going to accidentally be dropping any data. Little has changed to the current process. It had to happen during a window where there was no data being loaded in a specific table. And then the final thing was the change that we would have made at the beginning, in the literal way, is to update the stored procedures in source control to make sure that they create any partition tables with CCI, and ensure that the table in SSDT is created with clustered column store indexes. So again, simple in SSDT, go and update those. The build ran nice and simple. Test that in DB fit. You go and use an ETL process in dev to make sure it runs the data through, no issues. Get to production, we deploy the table change, and this is the funny thing, is the fact that when we deployed the table change, actually there was nothing to deploy. Because in source control, we'd updated it at CCI, but we'd actually gone through that whole process to deploy the database as a CCI. So when that source and target was done by SSDT, it would go, no change here, nothing for me to do here, just move on. So there was no chaos there, basically. We deployed the updates to the stored procedures, and then when the new jobs were being, when the new loads were being done, it was using the new stored procedures, checking it into the CCI table. And because we had a monitoring process around data loading, we were seeing, are there any issues in loading? And we had to keep an eye on the CPU, because when you create, even the partition table, when you go and create it with clustered column store, it generates quite a lot of CPU. And if you want to get the optimum amount of segments and you want to get the optimum amount of dictionaries for your partitions, for your clustered column store indexes, it's better just to load it into a heap table and then create the clustered column store after the fact, and it will go and figure it all out for you. And it's quite a CPU-intensive task, right? So we had to keep an eye on the CPU to make sure that there weren't some big spikes during the data loading process, and et cetera and so forth. So this was the process in which we kind of took what SSDT would have done, and people complain about SSDT, and actually turning it into kind of like a very controlled, very kind of risk-averse way of deploying a change. And it was through this process of just following things through, making sure nothing was going wrong, and then go, right, now we can move on to the next step. And it's not exciting in Minecraft to think about digging a hole in the ground and hiding yourself under some dirt to escape from mobs. What you want to do is you want to go and build something exciting like this. But really, coming back to the original point, is that if you want to get there, but if you really don't know how to get there, then all the mods and all the tools just won't help you. Just like SSDT, you can't really blame the tool. It's just doing what you've asked of it. And yeah, that's me done. I didn't really leave time for questions because it's only 20 minutes. If you've got any questions or you want to come talk to me afterwards, feel free. I'm not used to speaking 20 minutes uninterrupted. I've got 3 kids at home, so you can imagine I'm definitely not used to it. So yeah, come speak to me afterwards, but otherwise than that, thank you very much.